Let's go over how to set up the STM32F and the FreeRTOS using the STM32Cube MX. You're going to download this free graphical configuration tool, providing here the link, and I'm going to go over a tutorial on how to set up the discovery board and the STM32Cube MX with Atolik, so you can enable the FreeRTOS and start playing around with these tasks on the application layer, and also understanding the concept of hardware abstraction layer, which are a bunch of device drivers to interface with the hardware. I'm providing here a link so you can have access to these driver and middleware components, more details. So let's go over this tutorial. After you installed your STM32Cube MX, let's start the application. Let's access the board selector here. Let's filter these by evaluation board. Let's scroll down, pick our board, STM32F4. Initialize all peripherals with their default mode. You say yes. And you're presented with the microprocessor and the pins initialized. Now here you have a graphical way of parameterizing your system. You have here access to your GPIO, DMA, watchdog, analog, ADCs, timers, your digital communications, multimedia, security, computing, CRC, and the middleware. On the middleware, we have our FreeRTOS, and before we enable the FreeRTOS is going to share the same timer as your C-stick. So let's go to the C-stick and pick a different timer. If I go here on timers, I see that 4, 5, and 8 are taken. So let's say select timer 6. And let's go to the middleware and enable FreeRTOS. Once I enable the FreeRTOS, I have access here to parameters. I can parameterize my FreeRTOS, and I'm going here on tasks and queues. By default, you already have one task. Let's go create another one, my task 2. Just press OK, and you'll have 2 tasks. We're going to use this task to blink an LED. Clock configuration, you don't do anything, leave it at 168 MHz. And let's save. I'm going to save this project under desktop, and I'm going to call FreeRTOS blink LED, and make sure now the tool chain we're doing that to compile the code for True Studio. Let's press generate code, and after the code is generated, we can open the folder or open project. I don't have the rest of the drivers or the software to open the project directly to True Studio, so I'm going to open the folder, and this is the project that I'm going to import now under my Atolik environment. So let's go to File, let's go to Import and Existing Projects in Workspace. Let's go to my desktop, and it's going to find the FreeRTOS blink LED. I'm going to port the code, and you get everything in your development environment. So now let's go over the main.c. And inside of the main.c, you see that the code is slightly different than what you're used to. We have here the tasks now created or declared, and you have our main function. Our main function initializes some stuff here, some peripherals and GPIO, and then initializes the 2 tasks, the default task and task number 2. And then it starts the kernel. It starts the scheduling of the tasks. And notice that you're never going to run code inside of the while one, because once you run this kernel start, you will be inside of this scheduler. So if you put code inside of the while one, you will never get there. So where are you going to put your code now? Inside of the tasks. So if I scroll down until I find the handlers of those tasks, I have here the default task handler and the task 2 handler, and I'm going to use task number 2 to blink a blue LED. So we have this function here that it's doing the delay for 1 millisecond. So if I hover, this is a waiting for timeout in milliseconds. And now I need to know which function am I going to use to blink the LED. Before, you will be using the GPIO underscore toggle LED. I don't have the driver loaded on here, but now we're going to use a different set of drivers. And if you go and you expand your drivers, now notice that you have your STM32F with the name HAL, so hardware abstraction layer driver. If I expand, I have the include and the source. And if I go inside of the include, so notice that you have all the same peripherals over here. If I do the GPIO, and if I scroll down so I can find the functions that are being implemented, I notice that I have my GPIO toggle pin, and this is the one that I'm going to use. All right, and receives that port. So let me show you where these pins are declared inside of your main.h. You have here the pins that were initialized using the cube MX, and we're going to use these LEDs. You also have access to the button, and this is the blue button and this is the reset button. So let's use LED 3. I think it's the orange pin. So this is the port, which is port D, and this is the pin, which is the pin that we want. And let's blink the LED every half a second. And the first thing that I recommend to do is to compile this time to see if you have any errors. Once the compilation is done, let's deploy the code inside of our board. The reason why I'm recommending to compile first is that when you deploy on your board, it's going to give you this red thing over here that seems that it's an error. It's not, but it's better to compile first and then knowing that everything is fine and working. Then if I press play, you will see the orange LED blinking at half a second. So this is pretty much it that you need to know, like in a nutshell, how things work. And now it's how to interact the tasks with the rest of the peripherals and do exactly the same thing that we have been doing, but we have the scheduler taking care of the tasks at predefined values. Once you have done the tutorial, practice number 1, try to implement lab 1 using FreeRTOS. Have in mind that the main loop of the FreeRTOS needs to be empty, so the scheduler is taking control of the tasks. So you are going to do your main task here from figure 1. It's going to be a normal FreeRTOS task. And then after that, practice number 2, just do the voltage monitor tasks of lab number 2. So try to see if you can set up the ADC working under the FreeRTOS.